Hello again. Welcome back. We're going to talk about the dermis, right? So remember that anatomy always determines function. So when we're talking about the dermis, we are going to be looking at a layer of connective tissue rather than epithelial tissue. So we're going to have lots of fibers, like the reticular fibers, collagen fibers, elastic fibers. There's going to be a lot more ground substance and space between the cells. And then we're going to have those fibroblasts that are those cells that are putting down the different fibers and the ground substance, all that extracellular matrix between those cells. And we'll also be able to then talk about some of the pathological conditions that we see and what happens with aging. The dermis might be considered the core of the integumentary system. After all, derma does mean skin, and it is distinct from the epidermis. Epi means upon or over. So epidermis is over the dermis, and hypodermis, hypo means below, so that's the layer below the dermis. Well, the dermis is made up of connective tissue, and depending on where we are at in the body, it's going to be about 0.2 to 4 millimeters thick. And the main fiber that we're going to find in the dermis is collagen. But there's also going to be some elastic fibers and reticular fibers that we see in the loose and dense or fibrous connective tissue proper. Right, so the dermis contains blood vessels and lymph vessels, nerves, and other structures, such as hair follicles and sweat glands. The dermis is made of 2 layers of connective tissue that compose an interconnected mesh of elastin and collagenous fibers that are produced by those fibroblasts. So the more superficial layer of the dermis that protrudes into the epidermis is the papillary layer. So that's where we find these upward finger-like extensions of the dermis, which are referred to as dermal papillae. That prefix papille means nipple. So these nipple-like protrusions into the epidermis are the dermal papillae. And the downward ridges of the epidermis are referred to as epidermal ridges. And these dermal papillae and epidermal ridges create a zipper that anchors the epidermis down into the dermis. The papillary layer is the more superficial layer that has those dermal papillae that push up into the epidermis. And the papillary layer is made of a loose areolar connective tissue, which means the collagen and elastin fibers of this layer form a loose mesh. This superficial layer of the dermis projects into the stratum basale of the epidermis to form finger-like dermal papillae. Within the papillary layer are fibroblasts. So where you see these dark purple dots, these are actually the fibroblasts, right? So where in the epidermis, we have the epithelial tissue. Those cells are a lot bigger. And the nucleus is about the size of this entire fibroblast. So these are small cells, and they're the ones who are secreting these fibers and ground substance. You might find some fat cells or adipocytes, depending on the specimen. And we also will find an abundance of small blood vessels. In addition, the papillary layer will contain phagocytes, which are defensive cells that help fight bacteria and other infections that have breached the skin. This layer also contains lymphatic capillaries, nerve fibers, and touch receptors called myciner corpuscles. The reticular layer is underlying the papillary layer, and this is the much thicker layer. The thicker reticular layer is composed of dense, irregular connective tissue. This layer is very well vascularized, meaning it has a rich supply of blood vessels, and it has rich sensory and sympathetic nerve supply. The reticular layer appears reticulated or net-like due to a tight meshwork of fibers. A lot of those collagen fibers, and if you look at the arrangement of them, they're kind of swirly in this, and that's what tells you it is a loose, fibrous connective tissue, and that is going to provide strength in multiple directions, which is why your skin can take a lot of pulling in many directions. There is also going to be some elastin fibers to provide some elasticity to the skin and enable movement. And so the skin can actually bounce back and go to its original shape. Collagen fibers will provide the structure and tensile strength, so resisting that pulling. And there will be strands of collagen that extend into both the papillary layer and down into the hypodermis. That's going to like kind of connect everything together. In addition, the collagen binds water to keep skin hydrated. The collagen injections and retin A creams that claim to help restore skin turgor, it's either by introducing collagen externally or by stimulating blood flow and repair of the dermis. That's where those claims come from. And so the arrangement of those collagen fibers within the reticular layer also form bundles. And those bundles create lines that are actually pretty standard in humans. And those lines are called lines of cleavage or lines of tension. Okay, so this stained slide shows the two components of the dermis. It shows the papillary layer and the reticular layer. Both are made up of connective tissue with fibers of collagen extending from one to the other, making the border between somewhat indistinct. The dermal papillae will extend into the epidermis. That portion belongs to the papillary layer, whereas the dense collagen fiber bundles below belong to the reticular layer. And in that reticular layer, you can start to see those bundles that create these lines of cleavage. Those lines of cleavage are important to surgeons because the cuts should be made parallel to the lines of cleavage. That way, the healing can happen faster. if you think about like a rope, if you were to just kind of peel off a couple of the fibers of the rope, you could repair that pretty easily versus if you did a transverse cut through the rope and you were to glue the two pieces of the rope back together, it isn't going to be the same. So that's the same way that these lines of cleavage should be cut. The cuts should be made parallel with the lines of cleavage so that way the healing happens faster and those fibroblasts can put down new fibers and new ground substance versus scar tissue. Scar tissue is a different type of tissue than the collagen and the elastin fibers put down by fibroblasts. That scar tissue is a fibrous tissue, and so the replacement of collagen with scar tissue is called fibrosis. And that tissue will not function the same as the connective tissue or the epithelial tissue. It's going to be different. So if you like look at the lines of cleavage here, right along that sternum, if somebody has open heart surgery, that surgeon has to go through the sternum and they are making a direct perpendicular cut to those lines of cleavage, which is typically why open heart surgery has that huge scar right along the sternum. And if you think about what happens to rubber bands that are put in the sun for a long time, if we're thinking about the collagen fibers that we find in the dermis, right? Let's connect that to what happens to people who spend a great deal of time in the sun or people who smoke. They end up looking like this. All right, so that dermis is going to have those collagen fibers, right? And it's broken down into two zones. We've got the papillary layer, which is a thinner zone of areolar connective tissue. And that areolar connective tissue has collagen, reticular, and elastin fibers. So there's going to also be a lot of space between those fibers and those fibroblasts. That space allows for storage of nutrients and water. It also allows for the mobility of leukocytes, which are white blood cells, and other defensive cells to go into the area if there is some kind of infection or that first line of defense is breached. That layer is also going to be rich in small blood vessels. The reticular layer is a deeper, thicker layer of the dermis, and that is going to be made up of a fibrous, dense, irregular connective tissue because those collagen fibers are not going to be all nicely arranged in a parallel fashion. They're going to swirl out in all directions, giving strength in many directions. And when these collagen fibers tear, it breaks them and we can end up with stretch marks, which is caused by stretching of the skin. And if we have damage to dermal blood vessels through like burns or shoe friction, that can cause a blister. And a blister is actually the serous fluid found in between the dermis and the epidermis. It's like where that zipper of the dermal ridges and the epidermal ridges and the dermal papillae basically being separated, and that basement membrane of the epithelial tissue being ripped off of the papillary layer of the connective tissue down below. So all of that fluid from the areolar connective tissue of the papillary layer, that serous fluid just starts to seep out and it forms a blister. On your left, looking at image A, this shows a pink epidermal layer and a blue dermal layer. The right arrow from the superficial region of the dermis points to the micrograph labeled B. This is the papillary region of the dermis, and you're looking at an electron micrograph of those fibers. So a right arrow from the deep region of the dermis points to the micrograph C, and that's showing the the reticular region. So I want you to look at the fibers making up those two different regions. They're both collagen fibers, but the arrangement of the collagen fibers is different. In the papillary layer, it's a much more of a loose arrangement, making that areolar connective tissue, versus in the reticular label, you can see how those collagen fibers create these bundles, right? And those bundles create those lines of cleavage. And so now you can imagine what a cut going across all of these fibers would do. It would be much more difficult to repair them versus if you did a parallel cut to these fibers. I also like this image because it looks a lot like the fibers of a rope. And if you think about the strength that a rope provides, a rope is, bundles of smaller fibers, and they're all twisted, but they're running parallel in the same direction, which gives them a lot of tensile strength. And that's what we see right here. You can see the thick layers of dense thread-like collagen particles there. Within the dermis, we're going to find different nerve structures. So if we orientate ourselves to the skin surface, these are the dermal ridges. And within that papillary layer, we're going to find the Meissner corpuscles. The Meissner corpuscles are mechanoreceptors for very fine or light touch. Whereas the Merkel discs, those actually are within that stratum basale layer of the epidermis that are also mechanoreceptors for touch. And then if we go deeper into the dermis, we're going to find Ruffini corpuscles, which are also mechanoreceptors, but these are going to detect stretch. So if there's any kind of pulling on the skin, and very deep in the reticular layer, we're going to find a Pacinian corpuscle. So this actually is the encapsulated nerve ending, and there's these concentric rings that go around it that can detect pressure and vibration. So this is going to be more of a deep pressure, somebody's like poking at you, and vibrations. These Pacinian corpuscles are relatively large if you think about them microscopically. They can be up to 1 millimeter in diameter, which is the diameter of a pencil lead. And so if you look at the left, the nerve ending is found right in the middle, and there are many concentric layers that are encapsulating that central nerve ending. And it kind of resembles a tiny onion, right? If we look over here on the right, we can see another Pacinian corpuscle here. There are some other structures that we're going to find within the dermis, such as the hair shaft. That hair shaft is on the outside of the skin, and then it will go deep into the dermis, and we will see this area around the hair that is called the hair follicle, and we'll talk about the structures of that hair follicle in another lesson. We will also find glands, like our sebaceous glands that are oil glands. They will secrete their oil substance into a hair follicle to lubricate hair. We will also find sebaceous glands known as sudoriferous glands that have long ducts that lead up to the surface of the skin. And we will also find that erector pili muscle. So when this muscle contracts, it will actually pull on the hair follicle and it will cause the hair to stand upright on its end. We will also find arteries and veins along with those nerve endings. The hypodermis is also called the subcutaneous layer. Sub means below, cutaneous refers to as the skin. It is a layer directly below the dermis and it serves to connect the skin to the underlying fascia or fibrous tissue of the bones and muscles. It is not strictly a part of the skin, although the border between the hypodermis and the dermis can be difficult to distinguish. The hypodermis consists of a very well vascularized, loose areolar connective tissue and adipose tissue that functions as a mode of fat storage, as well as any nutrients that are lipid soluble. And it also provides insulation and cushioning for the integument. The hypodermis is home to most of the fat that concerns people when they're trying to keep their weight under control. Adipose tissue is present in the hypodermis, and unfortunately, that hypodermis consists of fat storing cells that are called adipocytes. And the stored fat it has function. It can serve as an energy reserve because we go into these fasted states. It does also insulate the body to prevent heat loss, and it acts like a cushion to protect underlying structures from trauma. For example, the kidneys are very superficial in the body, and so they are coated with this layer of fat to protect them. And fat really does get a bad rap. Where the fat is deposited and accumulates within the hypodermis does depend on hormones like testosterone, estrogen, insulin, glucagon. Leptin is a hormone that is secreted by these adipocytes, especially when they start shrinking and using the fat that they have stored in their vacuoles. They'll release leptin that makes you hungry, so you want to go eat. There are also some genetic factors that are going to determine where you store this fat. And fat distribution also changes as our bodies mature and age. Men, due to testosterone, tend to accumulate fat in different areas, like the neck, arms, and lower back and abdomen, than women. Women will tend to accumulate fat in the breast, hips, thighs, and the buttocks. The body mass index, or BMI, is often used as a measure of fat, although this measure it's really derived from a mathematical formula that compares body mass to height. Therefore, its accuracy as a health indicator, it's really can be called into question, especially for those individuals who are actually extremely physically fit. And if we look at our little animal friends, there is a pattern of storing excess calories as fat to be used in times when food is not readily available. In much of the developed world, insufficient exercise coupled with the ready availability and consumption of high calorie foods produces unwanted accumulation of adipose tissue in many people. And although periodic accumulation of excess fat may have provided an evolutionary advantage to our ancestors, who experienced unpredictable bouts of famine, it is now becoming chronic and considered a major health threat. In fact, recent studies indicate that a distressing percentage of our population is overweight and or clinically obese. Not only is this a problem for the individuals affected, but it also has an impact on our healthcare system. Changes in lifestyle, specifically diet and exercise, are the best ways to control body fat accumulation, especially when it reaches a level that increase the risk of heart disease and diabetes. And the thing about these fat cells is they are immortal. Once we make a fat cell, we have it forever, and it is always going to be ready to take on any extra calories we consume and store them as fat. That's why it's so hard to lose weight and it's so easy to gain that weight back because these fat cells, when we lose weight, their fat vacuole will shrink, but the fat cell itself, that adipocyte, is there and is ready with its to fill that vacuole with any extra calorie that you consume. So we will talk about additional structures of the integument in our next lesson.